Hey guys, in this lesson we will talk about transformations of exponential functions. We know the general equation for transformed functions is y equal to a f, then we have kx minus d plus c. We know this f stands for the function because here we have exponential functions. So for exponential functions, this can be written as a function is base to the power of x, so b is the base. X gets raised up as a power, so does k and d. So this is how we would write it down. K is factored out of x minus d plus c. A and c go at the same level as b. Only k, x, d are raised to the power. So this is the general transformed equation of exponential functions. Meanings of a, k, d, c stay the same as we have learned in Introduction to Functions unit. That was unit 1. If you want more clarification on transformations and its basics, I would recommend you to watch Transformations of Functions in Introductions to Functions playlist of the YouTube channel. So once we know the equation is y is equal to ab to the power kx minus d plus c, then we can draw out our transformation parameters. If a is greater than 1, it means it's a vertical stretch. If a is in between 0 and 1, that means it's a vertical compression. If a is negative, that means it's a reflection over x-axis. If k is greater than 1, it's a horizontal compression. If k is in between 0 and 1, it's a horizontal stretch. And if k is negative, it's a reflection over y-axis. If d value is a positive value or any positive number, that means it's a horizontal translation to right. And if d value is negative, it's a horizontal translation to left. Similarly, if c is positive, it's a vertical translation up. And if c is negative, it's a vertical translation down. This is how we write down the parameters. Let's do one example. We can also use these parameters to draw graphs using mapping formula. If we're asked to write down transformation parameters for y equal to negative 3 to the power of 2x minus 4 plus 1, and then turn this equation into a graph and write down its domain and range, we can do all this using these transformation parameters. So first, we would write down the general transformation equation. We know the general transformation equation is y is equal to a b to the power of kx minus d plus c. Now from here we can draw out our transformation parameters. We know b is the base, and here base is 3. So we can write down base is 3 in this particular case. We see that k is factored out of x minus d, whereas here k is not factored out. K is the number that is being multiplied or divided by x, so we have to factor that out first. And we can rewrite the equation as y is equal to negative 3 to the power of 2 is factored out. We are left with x minus 2 plus 1. Now we know a value is negative. No number means a is negative 1. K value is 2, so k is a positive 2. D is 2 as well, and C is 1. Now we can write down their meanings. A is negative 1 because we know A is greater than 1 is a vertical stretch, and A is in between 0 and 1, it's a vertical compression. Here it's exactly 1, so it's neither a stretch nor a compression, but there is just this negative sign that has a meaning, so we can write on reflection over x-axis. K is equal to positive 2. Means it's a horizontal compression by a factor of, whenever we write on statement for k, we always invert or we always reciprocate the k value. So it becomes factor of 1 over 2. Next we have d is equal to 2 because it's a positive 2. So we would say it's a horizontal translation by 2 units right. And finally we have c is equal to 1. So it's a vertical translation by 1 unit up. This is because this is positive again. Now if you want to use all of this information and draw a graph of it, how do we do that is we would use mapping formula. Let's rewrite down the equation first, and I'm gonna write down this equation that has k factored out already. So my equation is y is equal to negative 3 raised to the power of 2x minus 2 plus 1. Now I have to write this equation in the form of table first and then turn the table into graph, because we have to use mapping formula. So the first thing we would need is the parent function table of values. So table of values we would first make is for the parent function, and the parent function here is y is equal to 3 to the power of x. This is x, this is y. So parent function is always b to the power of x. B here is 3, so that's why we are writing 3. X values that we're supposed to take is always recommended as negative 1, 0, and 1. It can be taken something else, but these are the easiest values. We know y is going to be when 3 to the power of -1 is 1 over 3, 3 to the power of 0 is 1, 3 to the power of 1 is 3. We do not have to make this graph, we have to make the graph of this function. So now to write down the table of values for this function, we write down the mapping formula in the table. We know the mapping formula is x by k plus d gives us the new x value. Then we have ay plus c gives us the new y value. A value we can write it on side as -1, k is 2, d is 2, c is 1. Now we do not have to look at the equation, we can just look at these values or these parameters on the side because we have already taken these out of the equation. X we have to take from the original or the parent function x, so -1 divided by k is 2 plus d is 2 as well. So it's -1/2 plus 2, which is a positive 1.5. Now a is -1 times y value we pick up from here, 1 over 3 plus c value is 1. We can put this on the calculator if we want. So this gives us -1 over 3 plus 1. This gives us a 0.7. Next we have is k is 0. 0 divided by 2 plus 2. So 0 divided by 2 is 0 plus 2 is 2. A value is -1 here. Y is 1 plus 1. So -1 times 1 is -1 plus 1 is 0. Next we have is 1 divided by 2 plus 2 is 2.5. Here we have -1 times 3 plus 1 is equal to -3 plus 1, which is a -2. Now one thing we have to keep in mind is that before making the table of values into a graph, or before turning this into a graph, we should know the horizontal asymptote, because as we have done in the previous lesson, there is a horizontal asymptote in exponential functions. And when you have a transformed equation, the exponential function horizontal asymptote is always y equal to 0. And in transformed equation of exponential function, the horizontal asymptote general equation is always y equal to c value. When we have a parent function, let's look at this parent function, y is equal to 3 to the power of x. This parent function has no c value, so its c technically is 0. So that's why the horizontal asymptote in this case is y is equal to 0. That's the reason in lesson 1 we had put in the horizontal asymptote as y equal to 0. But now we have a y equal to c value. So c value is 1 here. Therefore, horizontal asymptote is y equal to 1. Now to turn this into a graph, we just have to look at the horizontal asymptote and we have to look in these table of values. So if this is the axis, the first thing we would plot is the horizontal asymptote, and the horizontal asymptote is at 1. So we would make the horizontal asymptote as a horizontal line passing through 1 on y-axis. Now we can mark our new x and y values. Now we see when x is 1.5, 1.5 would be here, y is 0.7. So let's say 0.7 is somewhat here. So when x is 1.5, y is 0.7. When x is 2, y is 0, which is going to be here. And when x is 2.5, let's say this is 2.5, y is going to be -2. When we join these points, this is how the graph is going to look like. So that means on this side, the graph should have been like this, because it's not supposed to cross the horizontal asymptote. So this is how the graph should look like. If you want to test the values of x that are smaller than 1.5, you can pick more x values and get the new y values just to see what is the trend here. But how we know this graph is going to be correct is, we know the parent function graph is y is equal to 3 to the power x. And we had drawn the graph for this in lesson 1. And that graph seems to go like this. This graph, the yellow graph, should be reflection over x-axis, and there should be a horizontal asymptote at y equal to 1, and this one seems like reflection over x-axis. So if a graph is like this, its reflection over x-axis would be like this. But since this is raised up, the horizontal asymptote, therefore it's a reflection across the horizontal asymptote. But the best way to make a graph is just to use the parent function x and y values, use them in mapping formula and get the new x and y values. Once you get the new x and y points, make the graph. Before that, always make sure that you make the horizontal asymptote. Now let's write down the characteristics of this new yellow graph. We notice from left to right, this graph is decreasing. So it is a decreasing graph. Next is it has a horizontal asymptote at y equal to 1. To write down its domain and range, we know domain is xer. Always remember, in an exponential function, there is no limit on domain. However, there is always a limit on range. So range is going to be YER, where Y is affected by A and C, because you see in the mapping formula, Y changes because of A and C. A decides the sign, C decides the number. Because the sign is negative, we would put less than, and C number goes here. We can write down the specific value. So it's YER, where Y is less than 1. And we notice that our y value is below 1 anyways. Now the fourth thing, that is the y-intercept. If we want to find out the y-intercept of any function, we know we have to put in the x value equal to 0. So in place of x, if we put a 0, 0 minus 2 is a negative 2, and we get negative 4 plus 1. When we put this on the calculator, we get 0.98765, or we can just say 0.99. That means it will cross the y-axis at 0.99. So the y-intercept is 0.99. And this is how we write on all the characteristics of a transformed equation after we turn it into a graph.